going strong. We have a phenomenal lineup today, and I'm especially excited for all the talks. Uh, these talks are made possible by our wonderful sponsors, Jazz Electric, SQL, PowerSync, and Bella AI. And we're lucky enough to also have James from Electric SQL today. So it's a good lineup, and stay tuned. First up, we have Ranger, who will be giving us a talk on what he's built up. I found his post and decided that this would make for an uh, interesting kind of local first talk. And he's going to be talking to us about Elastic, the repo. I'll post it in the Slack channel, and all of the slides and everything will be shared after the calls for those that have shares of PDFs or exports of their slides. And over to you, Ranger.
Okay, so now I'm sharing my screen. Can everyone see me now?
Yep,
Is it,
yep, coming in
can you
great.
see me for now? Okay, so I'm talking about Elastic, and the curve is all you need. You all know about attention. It's just a page spin with HMAC. Okay, so I'm starting with this stupid trick. You're on an HTTP server. I send you request, and you respond with response. Everyone might have done this. You're on a Linux machine. Pretty fun, right? So when I use a get, it does a web search, and it returns me with metadata of its what's searched, and it gets a body as a content. And interestingly, because it has numerous amounts of HTTP information, it gets to output this. Oops, but sometimes it can be a bad request because I want it to write down the artifact. It says, I don't know what you are talking about. And reversely, it sends me a HTTP request. It says, I need a topic, a file name, or something. Oh, so I gave it the data to say, please write my findings into Markdown. And bam, it created in a form of artifact. This is pretty funny, right? But you realize that this is how HTTP is working. So why this is funny? When we're doing prompt engineering, actually we're just smuggling protocol into the conversation. You said, please write Markdown. This is a content type. You said, this is urgency. This is urgent. It says, this severity is high. These are the control planes, headers hiding in the payload. I was just learning information theory recently, and I saw that Shannon would be very angry about this. So the problem is the envelope gets warped. Imagine every time AI wakes up and don't know what to do. We just stuff everything into its context window. It doesn't have a place, has a method, has a header, the metadata, and you are feeding it through only one flattened context, an API log. Why don't we just give it the envelope? So basically, every AI API is just an HTTP over HTTP. Why? When you try to input the modal field, it's URL. The row field is X row header. Content field is a body. And we have MCP. We have two views. They are all JSON formats inside the HTTP payload. What if we just use HTTP? I'm talking about why this is not a joke. It's a bad design to stuff all the metadata information into the payload. Because when you stuff that into it, the Nginx, the Cloudflare, every HTTP-based infrastructure, they get blind. They cannot sort. They cannot know what is the most important, what should be limited. I would like to ask a very simple question. What's an HTTP server? It just accepts a request and returns you something. An AI API, it returns you something. A real HTTP server also returns you something. But the AI can cheat you. A real HTTP server, it has nothing to do but to give you the real information. One might lie, one can't. So in the prompt engineering part, it's just cosplay. What if it is true? This is real. What if it's actually a HTTP endpoint on your own machine with real storage and can be mapped as a web dev, and you can edit, see it locally, and it has an address to read and write, and that's elastic. What's elastic? Elastic is just one, yeah, it's just a pastebin. We create something, it's created. And this is the example context. You see it in browser as HTML. You see it in web dev. Oops, I put txt here so that even if it writes bad code, you cannot just open and run that. You can query it locally, same data with many different mouses. I'm not giving AI a card and any agentic UI, any predefined stuff. I'm giving it an address to write in. So for the headers, they are the control plane. If I query something, like I audited my software supply chain and find the H11 is preferred, I'm putting the metadata inside the whole inside the headers instead of any paragraph of the body, because that makes sense. Headers are made for this. They have the metadata that are useful for human and AI reading. So semantic HTTP. We all know HTTP semantics. Now I'm saying semantic HTTP. What's semantic HTTP? What kind of representation I want from my data? What if we just see something different based on my preference? Everyone has a grammar. We might say, oh, my eyes are really bad. I don't want to see the fancy stuff. Just make it less fancy as possible. And that's basically accept something. And yeah, you can see that. You can tell that this is a trick by putting the prompts inside it. But it's not breaking the HTTP semantics. It's expanding HTTP itself. And most importantly, there is a shaped URL here, means under the shaped, you can see the AI generated. But you can always go back to the raw one and see the raw data. And the most interesting part is that the server can say no. Why? Because when you send accept image PNG, the language model says, sorry, I can't assist with that. But it can if you attach it with stable diffusion. It can draw your content and then present it to you. So the main point is that we should query our data, not the AI. What happens when we use the AI platforms? We start configuring MCP servers. We start looking at, oh, what app can I connect to the AI? We are querying the AI each time we talk to it. It is the platform. When it's offline, you are stuck. You don't know how to work. But if you query your data, you can query data in a raw format, see your data. You can query it under shaped URL, and AI help you enhance that. AI becomes hot pluggable. It is the infrastructure that acts behind the HTTP server. You focus on how to use my data well instead of just writing prompts. And the code doesn't care. And that's the point. And some might say that, hey, that requires API, blah blah blah. I still want to use chat interface. Yes, I totally agree, because chat interface is the best interface I've ever seen. We like chat interface, just like programmers like terminals. They are straightforward. They are interactive. Your prompts are basically the STD in, and AI's response is the STD out. But what's the problem? The problem is you can see your bash history inside your computer. But for the AI chat conversation, you have to wait for 24 hours to export that. And no internet. Oh, you're dead. That's the problem. Your AI chat has worse data locality than Unix terminal. So here's the point that when you insist on using the chat interface, Elastic becomes the T. We all know T in the Unix command. It's this simple, just putting in the stdls, also a file. The worst one is just only chat interface. Close tab, you are done. And interestingly, you can see the cloud artifact here. Why I'm mentioning this? Because cloud artifact is also T, but the product of the AI stays on their server. And we always have the illumination that you have access to internet every time, and your account is always safe. If you use Elastic, you can output the AI output into your own SQLite file. You don't have an account, you have a file locally. So much about introduction. How to do this? Pretty simple. We all know Cloudflare to know. It gives people who doesn't have a public domain, a temporary domain. You just tell the AI, hey, please write to this. And here is the bearer. Don't forget to change that afterwards. And here's the screenshot example. I said, hey, Claude, please help me curl into my own server. And now it has the bash tools. It happily just writes the authorization, the text markdown, and my temporary public domain. And bam, everything is now on your computer in the local host. It just wrote down all its findings. And now the semantic HTTP begins to work. In prompt engineering, it's just cosplaying a server. But for now, it's a real client that curls your server. Your server stores the metadata. How did it find the data and what the content is on your disk and with receipts. And for now, HTTP is fully used. Shannon is pretty happy about this. Well, actually, it doesn't always work because once I've encountered things like this, it says, no, I don't want to put that because you just give me a random Cloudflare channel. No. And it gives suggestion that the data is yours already. You can do it yourself with one crew. What's that? That's exactly the topic. Crew is all you need. Whoever crews it, it can be AI, it can be yourself, or you just copy and paste that current. Talking too much, it's showtime. So you might think that what's Elastic? It just look like there's a FH here, and there's a test word, fully empty and boring. I made a slow write screen after it slowly writing. It says what? AI can stream this too. This is plain text, but you can wait for the magic to happen. Why? Because AI can literally write anything. What's this? This is an HTML label. Oh, this is a bold. And what's what happen next? Wait for bold. Oh, why it has CSS? Oh, why? What happened? It's just streaming into there.
Wow.
This script is written by myself so that I can show you. But what if the backend is AI? It can create anything just instantly, locally, interactive. That's it. This is the showcase. Yeah. So one problem, what if the AI doesn't have curve? Like it refuses curve, or things like Gemini or any DeepSeek, they don't have curve. Ah, I say the text in your browser. Zombie is right there. I believe there always a way. Life finds a way. Regarding the local first topic, I'm not saying that Elastic is a product or anything that tries to replace CoachDB or any other stuff. I only assume one owner, one stream, and one moment. It's just a local HTTP interface before the production. It just gives AI a place to store, and also for human. It just speaks HTTP, not MCP, because HTTP is most common. Actually, let me show you. Do you know what's this? Elastic is just a paste bin. It happens the same if I just put a simple paste bin. See, this is the HTML. They're all strings. What's the difference? The difference is just it doesn't render here, and it's renders here in an iframe in a safe way. It's just a paste bin, a blackboard for you and for AI to write in. So it stops being a joke because we found that HTTP is enough and the paste bin is enough. And AI can act as an infrastructure. Not because the HTTP is new, because it still works. It was invented 30 years ago. Finally, it gets the user, the best user, AI, who is not lazy in writing the headers or anything stuff. Lastly, I would like to talk about big picture. What if the AI API headers actually mean something? For now, we're just exacting the content. Please analyze this, and here is this, and here is that. What if the AI API header has a built-in get contact and write to somewhere, and then trigger a webhook, and finally it's done. You can just do the plumbing, the Unix pipeline inside it. But I'm might be it might be a bit sad because if AI companies allow this, no doubt you are just directly right into your local host. The data goes home. Your artifact does not belong to their server. You don't have to wait here because it works just now. You can tell AI, please write to this code. You have to do some prompt engineering here. So we just start with that one that just works. So this is Elastic. It is just basically a paste bin, but it tells us crew is all you need and HTTP is all you need. It stores strings and subshapes. Thank you, everyone.
That was a
Any
pretty cool
questions?
talk. You've kind of broken a lot of our world models, so it's kind of we're trying to like catch up. The streaming into text into a DOM that gets rendered was quite interesting too. If you stop sharing, I'll
Yes,
be able to get James on the deck. Uh,
probably.
and it's going to work out pretty well with his talk right after yours. Um, like, can you even sync all the way into the model's backend? That would be an interesting kind of story. Here's James. You guys
Mm,
know he's a wonderful sponsor and a repeat speaker, and he was the
mm.
co-organizer of SingConf with me. He's the organizer of the upcoming Local First conference. Make sure you get your call for speakers submitted. You have 2 days left. And without further ado, over to James for what I am sure will be an epic talk.
Awesome. Thank you. I can share. There we go. As you say, this does continue a little bit from Ranger's talk on Elastic. We are big on HTTP protocols and curling data, and we similarly believe that agents are not compute. Agents live in the data layer. And then when you deploy lots of them, multi-agent systems become a distributed data problem. And the substrate for that is a sync engine. And so that's what I want to talk about today, is a little bit of work we've been doing on Electric around building this. But I'll go from first principles. So what is an agent? Well, an agent is basically an LLM in a loop. And what we all found out is if you take this loop and you run it on a computer, then the LLMs are really good at using the computer. And so you have all these agent harnesses like Claude Code, Codex, etc. And they all work by using the file system and bash and grep and things. And so obviously that's been great so far for software development. And in fact, it's completely reinvented software development. But it doesn't take us to the next step. So this is Sunil and Kate from the Cloudflare Agents team, just talking about the waves of evolution in agent infrastructure and how the next wave is this third wave of durable, distributed online agents. And it's the equivalent of the shift that we're all experiencing in software from development to factories, but then not just applied to software, it's the factory pattern applied to everything. So the whole sort of premise here is that this is like all knowledge work. It's about how do you bring agents online and integrate them into existing business processes, teams, collaboration, governance, etc. And then, so our view as a company on this is we look at this from an infrastructure point of view. And if you look at what your options are today to do that transformation, to go from agents running on local computers to agents running online, like what do you have? And it's these kind of things we're looking at here. You have a whole load of harnesses running in sandboxes. You have actor patterns, things like durable objects, and you have lots of people with workflow systems. And in a way, these are all ways of modeling the statefulness of agents. And they're all primitives that were available pre-agent, right? So agents came around being these kind of new stateful entities, and it's like, well, what do I have to be able to model these? And these were the things that we had from the kind of web service era that we could repurpose. And they've all been like very enabling and helping people to actually use and deploy agents, as we've all been just sort of scrambling to first base to make things work. But they are not going to take us to this next stage of distributed durable agents, because they are all based on a fundamental misunderstanding of what agents are. So if you take sandboxes, they basically lift that harness off the local computer into a VM or a container in the cloud. And this makes two key mistakes. The first one is it enables the fragmentation of resources within the sandbox. So the agent can just freely use the computer, but then there's no actual visibility into what it's doing sort of inside the computer. But then the second point, more profoundly maybe, is that it models the agent as a compute node. And that is just obviously wrong, right? Because then if the compute node dies, the agent dies. Agents are not processes. Agents are not nodes or services or pods. They're not defined by the compute that they run on. Agents are long-lived logical entities. They exist even when they're not running. And so they're actually defined by their conversational history and their memory and state and so on. And so they live in the data layer. And specifically, agents are logs. So the durability, the statefulness of the agent actually lives in the session log. And so if you then look at the other options, actors and workflows, well, they do model agents on a kind of log, but then they make the next key mistake, which is that they guard access to the log and they trap it behind a predefined interface. So for actors like a durable object, you have a web service interface which sits between you and the underlying agents. And so if you want to subscribe to it or monitor it or curl it, that has to be allowed and exposed by the web service API. And then for workflows, the log is not really a session log. the log is a kind of memoization tape for replay of the workflow steps. And again, that workflow is predefined. It's guardrails for the process, but it is a straitjacket for the agent. And so in both cases, the agent can't actually do things that the interface author or the workflow author didn't anticipate. And that is just a massive failure of imagination. Agents are not processes, agents are not workflows, agents are dynamic, spontaneous, intelligent, creative. So they spawn and communicate through distributed dynamic topologies. And when you conceive of agents like this, which is kind of like a mesh of data streams that plug into each other, and then it's like dynamically evolving clockwork, you can see that the substrate for that is a sync engine. Because a sync engine is the technology to tame the complexity of a distributed mesh of data streams. Because it handles all of the data wiring and all of the distributed systems complexity that as an AI engineer, as a product builder, as a platform builder, you don't want to have to deal with. And so this is what we've done at Electric. We've taken our sync tech and we've built the first agent platform based on sync. And it's one that models agents as long-lived logical entities that live in the data layer. So specifically in durable streams. And then every agent gets its own stream. That's how you communicate with it. That's also where it lives, where it exists. And then we have this whole layered stack of stream-based data primitives that the agents can use to spawn their own topologies. And it handles then all of the data wiring and communication and coordination through the data layer. And then because the logs are on the outside, in a way, this is the analogy of turning the database inside out, or this is turning the agent inside out. The logs are persistent, addressable, subscribable, resumable, forkable. So it means that anyone, other users, other agents, other systems, other teams, they can all subscribe and connect to the agent sessions at any time. And then because it's all standard web tech under the hood, you can integrate it with anything. And so just like our core sync tech, it's designed to work with your stack. So specifically how it works is you define agents as request handlers, a bit like the way you would define, say, workers as request handlers. And then these run in your web app or can be deployed as serverless functions. And so it's your agents in your code running in your app on your compute. And so in a way, it's the primitives to be able to achieve this sort of managed agents pattern, but without the platform lock-in that comes from people like Anthropic or OpenAI. Now, one of the points I just said was that you could then deploy agents as serverless functions, and which you may be thinking, agents and functions, like how does that work? Don't they need isolation? Isn't that the whole point of sandboxes? So you can let the agent make arbitrary tool calls and execute arbitrary code? Well, actually, no. And that's the other really interesting difference between the kind of previous wave and third wave infrastructure. Because when we were just scrambling to make things work, as I was saying before, it was kind of okay to have this kind of fragmentation in the sandbox, where the agent works by the harness just executing and spawning anything, and then the artifacts and the session logs are hidden files basically in a Claude folder. But that's not okay anymore. Right? We need to integrate the agents into online systems. And so the key enabler for that is to separate the agent logic from the tool call execution. Because you want the tool calls to be executed on systems that you control. And so it's actually by pulling apart the agent logic from the tool call execution that you can properly do this thing of wiring agents into your business systems. So that's why you run agents in functions. And that's why we built an agent platform based on sync. And this is a little early preview of it for today's LoFi meetup. But you can already run this command on the website, and this stuff will very soon be out in public. And that's the end of my talk.
As always, wow. Also, like the animation, you need to give me your info, like how you're pulling these things off. They drive the point home like really well. The curl and the electric kind of story kind of blend in really nicely for me from a position of like all the way to the back end, and then like having it be able to be stored, like the memory and the storage and the progress being able to be interfaced with different lenses. So the curl localhost lens to the same agent execution, and also the sort of browser-based log view from Sentry to find out what went wrong. These are kind of interesting. If you stop sharing, I'll be able to pull up Chad. He needs no introduction, but you just got to do it, you know?
There we go.
All right, next
Hello.
up, we have Chad. He was the first time I met Chad was in the local first Berlin meetup, the first one ever. He was the MC. And then from then on, I learned like all of my favorite people are like big fans of him. Subconscious was something that I've followed for a long time and like realized they're plugged in with Blue Yard and all that good stuff. I will hand it over to you now, Chad.
All right, thank you. Hopefully I can be half as coherent and interesting as Ranger and James. Really cool stuff. I probably can't be as coherent because I want to talk about a few different things. Well, at least two. So I'll just get started. So you probably all remember, let me make sure I'm sharing properly. I am, yes. 2023, like, oh wow, maybe we could like generate code with this thing. Maybe someday people will actually submit things that weren't reviewed and actually use them in production without reviewing them. And this has progressed over time. The last few months, it's gotten to where it's just like clear that everyone will commit AI generated code without reviewing it, which is scary. But I've been thinking about this since like 2023. I started using something called Open Interpreter, which was like the precursor to Claude Code and all those sorts of tools. So you could do like agentic autonomous development. It was really annoying back then. But I always knew that there is a shape of code that I would trust, and I would actually like deploy this code for real if I had an LLM generated. And the way I would think about it is normally I'd say, if I ask for a pure function with no side effects and Haskell, which has a great type system, it's compiled, and there's no side effects is an important part of it, I can pretty much trust that what comes out of the LLM is going to be right. And this has been true for a few years now. And so I started thinking a lot about, well, what is the gradient? If that's true, and pretty much everyone I would talk to, a year ago or so would agree. That's true. Like if you have a constrained thing in these various ways, it's going to work and you can pretty much trust it. What is the gradient and how do you apply whatever lessons exist there to everything? How can you build a whole system this way? So, and also, just like what does shape mean in this context? Backing up real quick, 2014, this is going to seem irrelevant, but maybe a lot of things I talk about today will. 2014, there was a huge vulnerability called Heartbleed in OpenSSL. And if you were working at the time, it's like the whole internet was screwed. Basically, every site on the internet was leaking all of the private data that was going through HTTPS. So I woke up that morning to a message from one of my trusted engineers and friends on the team. I was working on Wunderlist at the time saying, we have to turn off the system. And I was like, what the hell? What happened? And then he showed me the news, and indeed we did turn off the system. A lot of people didn't. We did because all of our users' credentials were leaking. Every single instance we had of a server was messed up. Every single instance had this fundamental library that the OpenSSL library that had a massive vulnerability. So at first we kind of had to just sit there because we were using AWS at the time. We had to wait for them to organize things. But we had like 100 services running live at the time, a bunch of servers. But because we were using this technique, which is now popular, called immutable infrastructure, we had, and basically immutable infrastructure means never change the server code that you have deployed, never change servers, just replace them, throw the old ones away. We were able to, in that day, completely script the replacement of every single aspect of our infrastructure, all within a couple of hours. And most of that was actually literally just waiting for the things to happen on the AWS side because they were DDoSed, basically. And we were able to fix that problem that day. Many teams took weeks to do it. And still, if you look this up, it's crazy. There are 250,000-ish servers still vulnerable to this thing. So be careful where you go. But I started thinking about, like, what happens if this sort of an attack takes place in a kind of black swan thing? Like, imagine like Lazarus group takes over NPM, starts infecting packages, and it becomes clear in a similar nightmare sort of day as Heartbleed was that we just can't trust NPM anymore, or whatever, whatever popular ecosystem and language and package managing system. How do you do the equivalent to what we did that day? Well, the answer has to be throw away all the code and the servers, right? So you've got a production system live. Well, how do you throw away the entire code? That's what this thing is about. It's about regenerating software. So the concept being, this is going to sound crazy, you've got all of your specs in a place, and you literally just say Phoenix regenerate, or whatever your system would be. We're going to talk about architecture here, but there is an implementation that I've been building. So code change is hard, right? And one thing I learned from one of my heroes in software, Kent Beck, is if it hurts, do it more often. So that's why we do things like test-driven development, because testing is a pain. So you should just do it all the time. So you have to be forced to do it in a way that is not painful, right? So how do we do code change all the time? What would that even mean? And sort of raising, actually, I'm going to skip this slide. This is what I'm trying to figure out how to do. How to create a system where the pieces are constantly changing and being regenerated. And I say this in the same way that, like, biological systems such as me are constantly being regenerated, even right now. Like all of us on this call, there are just trillions of cells dying at this moment. So how is it that we're still the same people? And how can we take that metaphor and apply it to software development? This is something I've been working on for years, but now in the AI era, it just ramps up. And you could get to a point where code is completely disposable and replaceable as long as you have an architecture that makes this possible. That's what this is. So you see github.com/chad/Phoenix is a reference implementation of this. Your mileage may vary. It's quite early, but it actually does sort of work. I'll give you an overview of what it does. So the way I think of software development now is that the ultimate target that you're creating, the code you're creating, is basically the target of compilation. But it's not compiling to binary code in the way that we've done in the past. It's compiling, this is going to be too small to see, but I'm going to just sort of talk through it. It's compiling from specifications, which could be markdown files, it could be transcribed audio sessions, video calls, etc. That compiles into a list of clauses. So you go through and you basically find everything in there that isn't or talking about the weather, but it's more statements about what the system should do. Then you canonicalize these clauses into actual, like a graph of requirements. And that's what this node is. At the same point here in this canonicalization step, for each requirement that may come out of the system, you could have agents or humans, if you're masochistic, go through and identify constraints and variants, all the sort of things that you care about in the system, how the system needs to behave in production, et cetera. And then from there, I'll talk about this more. You generate code, and that's in a two-step process. The first one being implementation units, which is this abstract notion of a piece of technology that needs to be created. And then finally, the actual generated artifact, so like a TypeScript file or something like that. The cool thing about this is if you do this in a Phoenix system and everything is done as a graph, then there is a connection between, for example, a specific line in a markdown file, the clauses that were extracted, all of the actual canonicalized requirements and variants, et cetera, and the evidence that must be poured back in to satisfy those requirements, and then the actual implementation units and code, which means you have a two-way provenance graph where you could say someone edited the code and therefore this requirement is not necessarily being met, or someone changed one line in one documentation or one document of 100, and you can still flow through and basically invalidate just the path to the one thing that needs to change because the requirement changed. This is the goal of the system and the architecture that I'm working on. And there's an important point here. I mentioned the implementation unit thing because as I started building the system, I realized, well, if you're going to be able to regenerate code all the time, and the idea is like maybe you don't ever allow old code to be in production. It always has to be new. What are you going to actually generate? What do you compile? What do you compile to? Most of us would assume that you'd be compiling to some language, some framework. Let's say it's a web app. It's maybe some sort of like a Node.js framework, Express or whatever. But I realized in order to satisfy that Lazarus group hypothetical thing where the entire Node ecosystem or Go ecosystem are compromised, you have to abstract away what you're compiling down to and compile into architecture. Now, why is this? One, because you want to be able to replace the language. Language is irrelevant now. The only reason to care about languages now are fast, secure. You can generate it. It's cheap to run. That's it, right? So you won't be using high-level languages in the future. You could get lower and lower level, get better performance, have the system be cheaper, etc. The other, though, is if you want to think of a system as a bunch of cells that can be regenerated, well, most of our frameworks are not built for that. We don't have those clear boundaries I was talking about at the beginning of like pure functions with no side effects. Now, no side effects is not a reasonable constraint probably for most systems, but we do have to create a system that is the overarching fabric for something that can have regenerated components inside. And that's what I mean by compiled architecture. So here's the example of how something like this would work. You have these declarations of what you want, which could be a markdown or whatever, that get compiled into requirements. Then the actual mechanical generation happens. Now, this is the interesting thing here. You then evaluate, and I'll talk about this in a second, based on actual production behavior or simulation behavior or both. And you can loop until you've actually found an implementation that you've generated that meets the requirements. So it could be that, for example, HTTP requests for a certain service have to happen within 50 milliseconds because it's required for the entire end-to-end process to be usable, that sort of thing. You first generate it in TypeScript, the implementation doesn't work properly, it doesn't actually meet that requirement, it's taking 100 milliseconds. So the system could just keep going until it finds the implementation that finally solves that problem. This is a trivialized one, of course. And then finally commit and say, this is the one that we're going to go with because it meets the requirements of the business. Then you record the entire derivation chain, as I talked about previously. You deploy and you place within some sort of system boundary. And of course, you have to design an architecture for each application that where these boundaries would be defined. And then I won't talk about the compact thing right now. So all of this requires that instead of thinking about code, the implemented code, you're not going to change that anymore in the same way that you don't edit a binary. It's irresponsible to do so, in fact. You will think about specifications that have these canonical requirements that have all the invariants, et cetera, and then evaluations. And so an evaluation ends up being really the code base or the set of evaluations because you use them as all of the input to generate the code that implements the system. So it's sort of like tests, but it's behavioral assertions that go across implementations. So they're not about a specific technical implementation. They're about what the system needs to do. In the same way that, similarly, that like formal languages do for formal modeling. And then the implementation unit thing I talked about, the reason that exists is because we want to be able to generate systems where the code isn't the asset, the system is the asset. So part of the system is to figure out which abstract chunks of functionality that are technical must exist that then could have implementations that get replaced in any language and ecosystem behind the covers. So, it would work like this. You've got an evaluation suite, and then maybe you decide, like, I want my system to be faster. I want it to be cheaper to run, et cetera. So you just keep optimizing and regenerating all the time. And one sort of unspoken thing here that I referenced briefly is the actual behavior of the running system should then not be something that just goes into logs that you can look at, the old way, but rather it is an input into the entire generation process. And I think we need to get really better about how we formally specify these things. And I mean, it doesn't have to be that formal anymore because agents can deal with a lot. But think about the output of your application as the input into the next gen of the code being generated. Imagine if you could do that with your brain as a software developer like 5 years ago. Amazing, right? Now you can. And I've been working on all this stuff because of a simple assertion that I made a while back, which is GitHub, and no offense to GitHub as an organization, but the tool as it is already obsolete. And you've all seen those things where like AI slop coding agents have been doing these terrible pull requests and basically just DOSing the maintainers. So GitHub was looking at just pulling like turning it off so that they could solve that noise problem. But I think it was James or someone said earlier, like, this is a systemic change. The way we do software is so different today for those of us who have caught up. The entire GitHub system is basically a collection of permissioned Git repos, and that's all it is. That's what it started as. That's what it is again. The user interface is completely useless at this point. And by this time next year, I can't imagine using it for a software development project. What I think we should do, though, is move to conversation. And this is the sort of segue into this thing I've been building called Freak. So imagine, just for a moment, there was a time where we were all saying, like, is it responsible to commit code that an agent created, or even to let the agent commit and deploy it? Most of us went through periods where, like, absolutely not, and then kind of loosen and loosen. And eventually, we're all sort of doing it. I would say there is a world where we flip that around and we say it is actually irresponsible for humans to commit code. And here's why I say it. Humans are lazy. They're time constrained. They only have so many hours in the day. There's only so productive we can be. We are not very disciplined. We don't like to write documents necessarily. We don't like to do all the compliance stuff that we have to do for certain jobs, et cetera. There's just all these things that we're bad at making ourselves do. We can make agents do it. And we can have thousands of agents, potentially. The only thing limiting us is like cost and environmental concerns, of course, but you can have thousands of agents review every commit for different reasons. So if you can like overdo rigor using automation, that it is irresponsible not to. In the same way that humans shouldn't have SSH keys to log into your production servers and change things. So I think in the future, the near future, the only responsible choice is that humans are not allowed to commit code directly. And I would even take this to another level and say humans are not allowed to talk to their coding agent directly and have it commit code. It has to happen in a public forum. And for this reason, I am building a thing called Freak. And actually, before I tell you what it is, and then I'll probably cut short, why does it have to happen in a public forum? Well, I think one of the things that we're really lacking right now, and by right now I mean for the last several decades, is as a software project that's a legacy project, ages, you lose track of the why of something. Like, why did this commit happen? I can see that it happened. We've got source control if people use it well. I can see when it happened, who did it, why did they do it? They changed this thing, like an exponential backoff parameter got reset one day, and suddenly 15 years later, there's a production outage because of it. Why was this way? Can I change it? I don't know. What if every single commit that ever happened tied to the conversation that led to the commit happening in a way that's content addressed, it's permanent, you can self-host it, etc. This is what I'm building. So Freak, you can log in today. There are clients for a bunch of different things. It's basically rebooting IRC on modern good rails of cryptography. So you sign in with app protocol, Blue Sky by default. It gives you your DID, and that becomes your actual thing in the chat. All messages are signed. There's first-class agent provenance. So agents are a thing. There's an agent SDK, and each one can be cryptographically tied to its creator / owner manager, which can happen hierarchically. And then you can have flexible channel policies. So you could, direct a software factory, for example. Here's a log of one that I did, where they would only listen to you if you were the owner or you had some sort of rights to direct them. So I'm imagining a situation now where you can do this obviously for closed or commercial teams, but imagine every open source project just has a chat channel that's in IRC. And the people who are collaborators on the project on whatever source control system they use are cryptographically verified with verifiable credentials to be owners of the project. So when they join the channel, they have special status, and they can actually direct the factory of bots that are working on the open source project. But then the entire community could join and either have a voice and speak, but not be listened to by the agents, or it could be moderated where only ops can talk, but they can at least see what's happening. And therefore, you see the entire stream of why everything is happening. And then how it led to the code, and the entire provenance is traceable. And I'm also building, if you know what IRC is, this is like IRC, but it's a base protocol that adds a bunch of stuff. So the goal is that you could replace closed, untrustable platforms like Discord that we're on now, or Slack, or et cetera, with something that you could host yourself that could be like on your local network, on your laptop, even if you wanted to. It wouldn't make much sense. But build Discord-like experiences so it has nascent AV with everything being programmable. So the idea is that agents could just programmatically join calls, listen, even provide input, and enable those things to then be inputs to the agents that generate code. So the provenance is tracked all the way to even a video call that happened with the transcription of the video call. Last thing I want to say is, and then I'm probably over time, is there is a local first-ish aspect to this, so therefore I get to be on this call. And the local first-ish aspect is the server-to-server federation, which is an IRC thing. So you got multiple servers, is done via IRO. If you don't know IRO, you need to know about it, IROH. We invested in it, but you should know about it even if we didn't, but just disclaimer. And then auto-merge CRDTs. And if you're on two freak native clients, meaning not an old legacy IRC client, but a new client, you can even do DMs, and it just auto-negotiates and uses IRO peer-to-peer for the DMs. So everything's encrypted by default. All the messages are signed, and everyone has a key. And with that, I will cut myself off because I've been talking too long.
So people, by popular request, you've been given another 5 minutes. I don't know how you're going to fill it, but I've already got it on mic and posted your talk.
Okay, cool. Then what should I talk about more? Let's see. Okay, so I actually don't even need the 5 minutes, I don't think, but thank you for giving me 5. One piece of pushback I've been getting on this Phoenix architecture stuff is like, of course you can't just regenerate the system all the time. That's crazy. And it is crazy. You cannot regenerate the system all the time. You can regenerate pieces of the system. And actually it was my friend Ben Schofield taught me about this idea of pace layers, which is a Stuart Brand concept of basically just like foundations or architectural layers of a product or system or anything that has a user experience. Each one can be assigned a pace, or assigned, probably not assigned. Each one has a natural pace. And so, for example, if you think about a regenerative system where code is changing all the time, you wouldn't regenerate the core operating system all the time. That doesn't make any sense, right? You want to get some things secure and solid. So it's all about both what things can change frequently and do so without so much risk, and which things should. So, for example, you could change the UI all the time and probably not introduce a bunch of technical risk, but as Google or Gmail figured out, you're going to screw your users up and they're going to complain even if it works, even if it's better today than it was yesterday. You don't want to have to relearn a UI every time you look at something. And so this is the way that I would approach this is, and you could codify it into a Phoenix type system where you just have paste layers. Some things are locked, they'll never be regenerated. Some things happen and they require, human intervention, approval. Maybe they require a special security audit or something like that. So that's the way I'm thinking about this. The core thing, I've been saying this for years, is, and I think we really need to get this into our heads now, when we're building software, the system that we're building is the asset and the code is the liability. We have fetishized code as software developers. I know I have for decades, because it was the only way to really truly express the love required to create a craft that makes software that is good. This is no longer true. Code is a liability. It's the more code you have, the worse your system is. We sort of always know this, or the riskier it is. If you can have a system that is great and has no code, that's better than a system that has tons of code, right? So start thinking in terms of the system. That's the thing we're building. That's where craft and rigor relocate to now in this world, not to code. If you're one of the people like I have been in my past that is just like an evangelist for a programming language or ecosystem or framework, I think you need to think hard about both what you're doing with your career and what potential impact you can have, because things are changing and the stuff that worked before isn't what's going to work in the future. So probably that's enough from me.
All right, wonderful, wonderful.
Thank you for your attention.
So we're going to go into the living room mode, which means the recording is going to be stopped, the screen is going to be